Hello, everybody. I'm back. Sorry, I think I reached the extent of the recording, so it canceled or it chopped me off. So, what we're going to do is we're going to continue with the notes. So, hopefully, it's the next day. You're all rested and ready to go. My hair is like a mess because this microphone is not making me have a nice hair day. But anyway, we'll go ahead and start where we left off, which is at the last page or the last part of page 3, and then we'll look at moving on to what to do when you're rounding with adding, subtracting, multiplying, dividing. So, um, let's see. Let me go ahead and turn off this camera and we'll start. Let's see if I can turn on the slideshow. Here we go. Okay, so we ended last time with looking at, I think it was this last one here, what to do when you're trying to write this guy in scientific notation after rounding it to 4 sig figs. So this one right here, if we want to round this one to 4 sig figs, so the fourth sig fig is actually starting from the 1, 2, 3 right here at the 7. So the neighbor is a 5, so that means that this 7 is going to turn into an 8. Okay, so we're going to do 1, 3, 6, 8, and then keeping with the original intent of the place value, we have to turn these guys into zeros so that way the place value is still the same as our original measurement. Okay, so turning that guy into scientific notation, we're going to need to remember that our decimal is hiding out at the end here after our last 0. So we're going to make a number bigger than 1 but less than 10. 1, 2, 3, 4, 5. So it'll be 1.368 times 10 to the 5th kilograms. And remember we discussed earlier that in order to know how many sig figs you have in scientific notation, you're going to look at this part, right? So you should know that there are 4 sig figs there, the 1, 3, 6, and 8. Okay, so that is how you write numbers in scientific notation to ensure you have the right number of significant figures. Okay, so moving on, let's look at what we're going to do next as a result of, okay, so what if we were doing measurements, right? Or we have our measurements and then we got to do some math. So how do we round our answers to make sure that our measure or our reported measurements are not any more precise than our least precise measurements? Because we can't, it's like, when you're playing sports, right? Your team is no stronger than your weakest player. So just like with precision, right? The least precise your measurement is can kind of be construed a weaker measurement. So the precision of your answer is dictated by whichever measurement is the least precise. So looking at your notes here, the word that goes in that blank is red there. It's its decimal point. So it says when adding or subtracting measurements, the answer must have the same number of digits to the right of the decimal point as the value with the fewest digits to the right of the decimal point. So what I suggest you do, if you're doing this by hand, you're going to need to line up your decimals just like when you were younger, trying to add up your numbers here. So we're going to add these together, and this is 254 without a decimal, so it goes like this. Okay. So when you're adding those two together, let's see, what does a calculator say? So remember, you need a calculator. I'm using my phone right now. So 2.77, 277.11 plus 254. Calculator answer is this, 531.11 kilograms. Now, is that something that we're allowed to report as far as a properly reported or rounded measurement? The answer is no, because if you look at this guy right here, right, this one, there's no digits reported there. There aren't any zeros there that would indicate that anything was measured past that ones place, past the 4. So by us reporting this, what we're doing is we're assuming that there's zeros here, right? But really, we don't know if those are zeros because our measurement or our measuring tool did not allow us to make that measurement all the way down to the hundreds place. Now, it would probably be like, if we use the same measuring instrument, then why don't we have the same number of place values as the 277.11? That's a good question. But in this case, since we're just adding these two together, whoever reported the 254 either reported it incorrectly or they used a different measuring tool, which was not as precise as the 277.11. So with that being said, we go back to our original definition or our original guideline here that when you're rounding um, a, a measurement after adding or subtracting, you must have the same number of digits to the right of the decimal as the value with the fewest to the right of the decimal. So between 277.11 and 254, which measurement has the fewest number of digits to the right of the decimal? Yeah, the answer you're looking at is this guy. How many digits are there to the right of the decimal there? None, right? So that means that your answer here is not allowed to have any digits to the right of the decimal because it is being limited in its precision by the 254. Okay, so what we have to do is round this guy to right here because that would then be dictating the correct number of digits to the right of the decimal that I'm allowed to have. So we look at our number, which is neighbor, which is a 1. So that 1, the 531, is going to stay a 1. So this is going to be reported as 531 kilograms. Okay, and the reason why is because of the lack of precision in this guy. Okay, so remember our answer cannot be any more precise than their least precise measurement, and with adding and subtracting, this is how you make sure that you accomplish that. Okay, so the next one here, we have, let me change my marker. So we have 0.0487 milligrams, and we're going to add 0.058 milligrams. Okay, if we add that in the calculator, we're going to, and let's just do the long math here. It's 16, this is going to be 10, and this is 1, and this is a 0 here, and this is milligrams. So what we're going to do is we see 1.1067 milligrams. Now, are we allowed to have all of those decimals to the right of the decimal? The answer is no, because we're looking at the fewest digits to the right of the decimal. We're not looking at sig figs to the right or anything like that. We're just looking at fewest digits. How many digits to the right of the decimal does this first number have? The answer is 1, 2, 3, 4. The 0, the 4, the 8, and the 7. There are 4 digits to the right of the decimal there. This next one, 0.058, that one has 3 digits to the right of the decimal. So in that case, you will have to have your answer here reported to have 3 digits to the right of the decimal. So 1, 2, 3, neighbor is a 7. So that means that 6 is going to turn into a 7. So reported measurement for this one will be 107 milligrams. Okay. So thereby you have 3 digits to the right of the decimal, which matches the same precision as this one, which is the least precise between the two. Okay, let's move on. Okay, next we have, what do we do when we multiply and divide? Well, the rule is a little different here. Okay, now we're looking at total significant figures. We're not looking at places to the right anymore. We're looking at total significant figures. So you need to round your answer to have the same number of significant figures as the measurement with the fewest sig figs. Okay, so let's do this math in the calculator here. We're going to have 24 times 3.26. And the calculator tells me 78.24. And the unit for this is going to be meters times meters, which is square meters. Okay. Now, I'm not allowed to report all of that because this is really, really a lot more precise than these measurements that are making it up. So how many sig figs are in 24? Yes, 2. Let me do that. Okay, so there's 2 sig figs here. How many sig figs are, let's move that out of the way. How many sig figs are in 3.26? 3 sig figs. So that means my answer here can only have 2 sig figs. okay, because it's going to be dictated by this one right here, which is 2 sig figs. So the second sig fig is right here at the 8. The neighbor is a 2. That means the 8's going to stay in 8, and everything else goes away. So this is going to be reported as 78 square meters. You might be thinking, oh my gosh, we're like really truncating these numbers here. Well, yeah, it's because you can't be any more precise than your least precise measurement. So thereby, it's super important that when you're making measurements, especially with a ruler, that you report as many digits as you can with that ruler as far as the precision and accuracy goes, okay? All right, so next we have 60.2 divided by 20.1. So that's going to be 2.99. My calculator is telling me a whole slew of numbers like this, and on and on and on and on. My unit is going to be meters divided by seconds, which is meters per second, which is a velocity. Okay. So looking at this, I'm only allowed to have the same number of digits as my as sig figs as my measurement that has the fewest. So looking at both of these, they each 1, 2, 3. This one has this one has 3 sig figs. This one has 1, 2, 3, also 3 sig figs. So that means my answer is only allowed to have 3 sig figs. So 3 sig figs, 1, 2, 3. Neighbor is a 5. Oh man, what do I do here? My 9 is going to turn into a 10, but then that's going to impact this 9, which turns that into a 10, which then impacts the 2, which turns it into a what? A 3. So this is going to be reported like this. Okay, so that is 3 significant figures, and it's appropriately rounded based upon what is being shown there for the number of sig figs in each measurement. Okay. So let's go. So we're going to do some extra practice, and then after this, what you can do is you can sit down with your classmates and go over more practice as far as your homework is concerned, and the answers will be there. You can use my binder to determine if your answers are correct. Okay. So here we have calculate and report the correct number of significant figures. So in this case, what are we doing? Are we adding, subtracting, or are we multiplying, dividing? Okay, so right, we are dividing. So we're not needing to worry about the adding and subtracting rule, because remember, that's different from the multiplying and dividing rule. Okay, so we are multiplying and dividing now. So we're looking at rounding our answer to have the same number of sig figs as the value with the fewest sig figs. So just like I said earlier, we'll just pretend that both of these are measurements. Okay. So 60.2, I think this is going to be the same as we did earlier. 60.2 divided by 20.10. Yep. So in this case, we're going to end up with that 2.995 situation earlier that we had. But now, how many digits are we allowed to have? This has 3 sig figs. This has 4 sig figs. But we're only allowed to have the fewest sig figs. So in this case, again, 3 sig figs, neighbor's a 5, so just like before, it's going to round to that. Okay, so we cannot have any more sig figs than our measurement with the fewest total sig figs when you're multiplying and dividing. Okay, remember your rules are different. Okay, so first you got to figure out, am I multiplying and dividing, or am I adding and subtracting? Okay, so let's look at this last slide here. So what are we doing here? Are we adding and subtracting or multiplying and dividing? Obviously, we can tell that we are adding. Okay, so we're going to add this in the calculator. Let's see, 0.38. So the calculator is telling me this is the answer. Okay, so we're over here at this rule, right? So our answer must end so that its last significant digit falls in the same place as the least precise measurement. That means we're looking at how many places to the right of the decimal does this have and this have, and then we're going to round our final answer to have the same number of digits to the right of the decimal as our measurement that has the fewest. So in this case here, the 0.0587, how many digits are there to the right of the decimal? Yes, there are 4 digits to the right of the decimal. It doesn't have to be significant, just digits, place values, okay? For this one here, the 0.038, how many digits are there to the right of the decimal? Should be 3. So that means that my answer can only have 3 digits to the right of the decimal because that between the two measurements is the least precise. Okay, So I'm going to round this to have 3 digits to the right of the decimal, which is 1, 2, 3. Neighbor is a 7. So that means that I'm going to report this as 0.096, and then that's it. I will not put a 0 here after the 6 because then that will count as a place value, and I'm only allowed to have 3 digits to the right of the decimal. Okay. All right. So we have just finished all of the notes for 1.3. I know it was quite lengthy, but I look forward to working with you next week when I return on some of these things. But as you are working on your practice, please make sure that you're getting the confirmation that you need as far as your answers are concerned. And I will see you soon. Bye.